Hey guys, today's lesson is science. We are going to use a gyroscope. If you don't know what that is, this is a gyroscope, and something interesting is this whole outline is the gyro, and this that I'm spinning is a scope. There's a little stand, and if I put it on there, and it's spinning at a high enough speed, which I will use this string right here. If it's spinning at a high enough speed, it will actually be able to stay upright and not fall, even though it looks like it should. Another science lesson I may do is Newton's Cradle, which is a very fun and interesting topic to learn about. I did not get it going fast enough, but it was going very fast. I don't know how I have not got it going fast enough. Never before have I actually, although I did just get it yesterday. My dad can do it, but I can't. Uh-huh. And one of the hard parts is getting it through the little hole. So then twirl it up like this, but then pull the string that gets it really moving. Okay, so let's go ahead and get her spinning. Yeah, I can tell that one was definitely not spinning fast enough. Let me see, where's my other string? Maybe this one's just worn out. But I'll get like that sometimes. Sorry, I had to scratch myself. At first, I was thinking to myself, why does it have two strings? But did you know the gyroscope, if it's spinning fast enough, it can actually balance itself on a string? I found that very interesting whenever I learned that. So I'm gonna go pull it over here. Then I gotta spin it back up. Remember, we all make mistakes, and this is definitely a mistake I'm making because I cannot fully properly do this. There we are. And this is called a gyroscope. Um, Newton's cradle is also something very interesting to learn about. I'm gonna pull up a photo of Newton's cradle right now because for Christmas I got something so that I can keep I can show you guys all this fun, cool stuff while recording. Okay, so let me switch up. Okay, now I can see y'all again. Uh, Newton's cradle. Which I do have a Newton's cradle with me. Uh, not on me right now, but I do have Newton's cradle. So I might as well just show it to you guys in real life. Sorry, I'm trying to unhook from my monitor. As y'all can see, just had to unplug the HDMI adapter. Now, where is Newton's cradle? Right here. Okay, so let me grab Newton's cradle. This is also a very fun science activity. I'll leave links on where you can purchase these. But this is Newton's cradle. This is how it works. So, I caused an output force, which stopped this. But now, I'm going to pull two balls with the exact same force. one comes out on the other side. Bar causes an output force, or a, a triple output force. And now, if I just take, now, I'm going to take 4 balls, bring them back. 4 come out the exact same side with the exact same speed. But what happens if I take all 5 balls? It just swings. Unless I put an output on it. Or, let's say I do it very lightly. The pressure, it just I don't know how it does it, but it's really cool. See, now I'm going to take 3 balls and 2 balls and have them collide. And if you really pay attention, they keep switching with each other. Now, it seems like magic, but really, it's science. Newton's cradle is one of the greatest creations in the world. But now I cause an output force, so now it starts to slow down. Bring it up here. It causes the exact same output force. The output force, like what I'm about to show you guys, causes it to stop. But if I take 3 and 2, like I showed you, it's like 3, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, 2. So it should run for about 50 seconds and then stop. But that's never truly been tested on how long it actually will run for. So let me pull up my stopwatch. Sorry, stopwatch. Okay. So we got my stopwatch right here. And we're gonna stop it. Okay, so reset stopwatch. And now we are going to pull this up. Start the stopwatch. Now, stopwatch is moving. We're going to see how long it approximately can run for. See, but I think the lower the force, the lower the slower it runs, and the shorter amount of time it runs. But the more the force, so the more that you take it, pull it up, and let it go, the longer it'll run. We're at around 35 seconds. It's not fully stopped. It has to fully stop for it to count. Amazon said it should run for about 50 seconds. Output force was about exactly 50 seconds. But now, let me restart stopwatch. And now, let's cause a bigger output force. Starting now. How much longer or shorter will it run for? So we know whenever we did it smaller, it only ran for about 50 seconds. But now that we're doing it bigger, it does look like it is partly slowing down quicker. But will this cause an actual effect, or will it stop at around exactly 50 to 51 seconds? I am noticing change in motion a lot quicker. So I'm wondering if it's the slower you run it, the longer it goes, because it's not having to put off so much power whenever I pull that up and drop it to put out the same force. So it's still moving. We're sitting at about 48 seconds. 50, 51, 52, 53. So we're going to stop it at 54.72. So we're in for 4 more seconds. That's about it. But now I really want to test it with a very low force. Starting now. So we're gonna go ahead and say stopped. We're sitting out at 21 seconds and 99 milliseconds. So I feel like it was pretty good understanding with Newton's cradle. Gyroscope was just an interesting activity. Really had no big thing with it. I hope you guys enjoyed today's video. Bye!